Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Radha Subramaniam with a PhD in Chemistry. So today we are going to continue with equilibrium part 2. Already I have uploaded the first session, equilibrium part 1, the most important concepts. So those who haven't watched the video can go back and watch that video and come to the second part. So today again I want to share the tips for NEET exam. As always I say the first thing is the key to success is practice. Nothing can be obtained when it is not in the routine, because when you look for something you have to pay for it daily, be it equations, thermodynamic solutions or numericals from organic practice. Practicing daily is the only key to being able to process all of this, and the concept needs to be clarified. Concept is never such a part that you can read it and get it. Concept is all that has to be understood and which clings to your brain forever. Chemistry is a matter of concepts. One who is good with the concept can know chemistry better. Once you clearly see each concept for what it is all about, you will be ready for the next step. Okay, with that we will move on to the concepts. Again continue with equilibrium. So we were talking about equilibria, then a forward reaction, backward reaction, then dynamic equilibrium. So many definitions and all, many laws, we all saw that in the previous session. So here what is meant by equilibrium mixture? The mixture of reactants and products is called equilibrium mixture. So a stage comes when there is no change in the concentration is what we call a dynamic equilibrium. Equilibrium which involves ions are called ionic equilibrium. So remember these three terms well. And next we have to look at the concept of the equilibrium. When a system approaches equilibrium, both forward and reverse reactions are occurring. Time again straight graph is given here. The equilibrium when it is actually the rates are equal. You see both equilibrium at that stage the forward and the reverse reaction will be proceeding at the same rate. And for solid liquid equilibrium there is only one temperature, melting point at 1 atmosphere, at which two phases can coexist. So there is no exchange of heat with the surroundings. The mass of the two phases will also be a constant. In the case of liquid vapor equilibrium, vapor pressure is constant at a given temperature. For dissolution of solids in liquid, solubility is a constant at given temperature. For dissolution of gases in liquids, concentration of gas in liquid is proportional to the pressure of gas over the liquid. So remember all these 4 points which are very important. Then equilibriums in physical process, already we learned something from that in the last session. Most famous example of physical equilibrium is phase transformation process, like solid, liquid, liquid to gas, solid to gas. All these are interconnected. See, solid and gas, solid, liquid, gas, liquid, gas, plasma. So you can see it over here. Now what is the relationship between equilibrium constant K, reaction constant Q gives energy G? So the relationship between these three are very important. If delta G is negative, reaction will be spontaneous and it proceeds in the forward direction. All these concepts I am repeating it again so that it will be active in your brain without forgetting. And if delta G is positive, then the reaction is considered non-spontaneous. Instead, as reverse reaction will have negative delta G, the products of the forward reaction shall be converted to reactants. Delta G is 0, reaction has attained equilibrium, and at this point there is no longer any free energy left to drive the reaction. Okay, now what does the value of K mean? Reactants and products, already we saw this also. If K is greater than 1, reaction is product for favored, product predominates at equilibrium. Reverse takes place when the former predominates, that is if K is less than 1. A mathematical expression of the thermodynamic view, how can you write it? Delta G is equal to delta G0 plus RT ln Q. At equilibrium delta G will be 0, Q will be equal to Kc. Then the equation can be rewritten like this, which is equal to delta G0 is equal to minus RT ln K, or you can write ln K like this, and taking anti-log on both sides you get this form. Don't forget, this is a very important formula. Next, applications of equilibrium constant. The expression for equilibrium constant is applicable only when concentration of the reactants and products reaches constant value at the equilibrium state. So the value of equilibrium constant will be independent of initial concentration of the reactants and products. Equilibrium constant is temperature dependent. Remember, it is always temperature dependent, having one unique value for a particular reaction, which is shown by a balanced equation at a given temperature. The equilibrium constant for a reverse reaction will be equal to the inverse of the equilibrium constant for the forward reaction. So these are the applications of equilibrium constant. Now, what are buffer solutions? These are solutions which can resist change in pH on dilution or with addition of small amount of acid or alkali. Now, buffer solution, how can you prepare? From the knowledge of pKa and pKb of base and controlling the ratio of salt and acid or salt and base, you can prepare a buffer solution. Then what is polyprotic acid? Often acid molecules, they have more than one ionizable hydrogen. These are called polyprotic acids. Ionizable hydrogen may have different acid strength, or it can be equal as well. 1H is equal to monoprotic, 2 will be di, 3H tri, like that. So polyprotic acid ionize in steps. Each ionizable hydrogen removed sequentially, and removing the first hydrogen automatically makes the removal of the second hydrogen harder. The sulfuric acid is stronger acid than HSO4 minus. So because here we have got two atoms, removal of second atom is more difficult. Now, amount of solvation enthalpy depends on nature of the solvent. So if it is a non-polar solvent, solvation enthalpy will be small. So sufficient, it is not sufficient to overcome the lattice enthalpy of the salt. So salt does not dissolve in a non-polar solvent, it dissolves only in polar solvents like water. So we can make a general rule here: for a salt to be able to dissolve in particular solvent, its solvation enthalpy should be greater than its lattice enthalpy, so that the lattice enthalpy can be overcome by the solvation enthalpy. And solubility of the gas will depend always on its temperature. What is ionization constant and ionization product? In pure water, one water molecule will donate proton and it acts as an acid, and another water molecule that will accept a proton and act as a base at the same time. The following equilibrium can be, the dissociation, we can write it like this: two molecules of water, you can write it as H2O plus H2O, it gives H3O plus OH minus. So K will be H3O plus OH minus, product side by reactant 1 H2, who can be written here. Acid plus base gives salt and water always. This is called neutralization reaction. What is dielectric constant? It is the ability of the polar solvent to dissociate in water. It is a measure relative permeability, and separation of ions in water is called ionization or dissociation. When ions of water are separated, we call it hydration. Organic acids like acetic acid, formic acid, they cannot ionize, can be partially ionized only, that is less than 5%. Acid and base strength. So strong acid can completely dissociate in water. Their conjugate bases are very weak. Weak acids only dissociate partially in water. Conjugate bases are weak bases. So you can see here the strength, weakness and all are negligible. Go through this chart, all of you. Now, solubility equilibria of sparingly soluble salts. So solubility of salts mainly depends on lattice enthalpy of the salt and solvation enthalpy of the ions in solution. If a salt should dissolve in a solvent, the strong forces of attraction between its ions must be overcome by the ion-solvent interaction. So the solvation enthalpy of ions is referred to as solvation, which is always negative, and energy is released in the process of solvation. So remember all these points. Next, what is common ion effect? This is very important. Then the reduction of concentration of hydrogen ion is called common ion effect. We can define it as a shift of the equilibrium by adding a substance which provides more ionic species already present in the dissociation equilibrium. Common ion effect is based on Weishadler's principle. Then general trends in activity: stronger an acid at donating H plus, weaker the conjugate bases at accepting H plus. Higher the oxidation number of an acid, stronger is the oxy acid. H2SO4 greater than H2SO3. And cations are stronger than acids than neutral molecules, and neutral acids are stronger than anions. Bases have an opposite trend. And remember this point well, that is the trends in acidity. Now, Lewis acids and bases. According to Lewis, he defines acids as a species which accept electron pair base, which donates an electron pair. So acids are species which accept electron pair, and bases are the one which donates electron pair. It is an here and not an. In Lewis concept, acid do not have a proton at all. In bases, a lone pair is provided in such cases. BF3 it does not have a proton but still acts as an acid and reacts with NH3 by accepting its lone pair of electrons. In ionization of weak bases, equilibrium constant for base ionization is called base ionization constant and represented by Kb. What is Kb? It is base ionization constant. Alternatively, if C is initial concentration of the base and alpha is the degree of ionization of the base, then the extent to which the base ionization and equilibrium constant, how will you write it? Kb is equal to C square alpha square by C into 1 minus alpha, or that is equal to cancel out the C alpha square by 1 minus alpha. So, I hope you keep on reading it and revising it so that the concepts get well settled in your mind so that you won't forget it. And always, as I say, please do like, share and subscribe to my channel, share it with your friends. Don't forget to press the bell icon that as soon as I post my new videos, you will get the notifications immediately. I will be uploading more sessions coming months, because as you all know, the NEET exams 2022 are most probably to be held in June end or July first week as far as we know. So all of you practice and keep on revising well. With that, we are coming to an end of this session. Thank you all for watching my video, and we'll soon meet up with another brand new session. Thank you.